Okay, so today video 2. Um, Again, hello. My name's Robert Harkis. These set of videos are just my musings, ramblings. I may edit them in the future, make them slightly more professional. I may decide to write some papers on their topics in here, in collaboration with other people. However, this is just my rambling. Apologies, I've got a bit of a cold at the moment. This this video is essentially climate change. It's essentially the change in climate. What causes the change in climate? Again, throughout history, just a little bit of background. Throughout history, there is we know there are periods of glaciation and there are periods of extreme cold within of our planet. What we do know is that these extreme glaciation periods are generally thought to be due to our planet's orbit elongating. So it's closer to the sun at some periods, further away at other periods. It's speculated that this may be due to the tilt of the Earth. However, we don't actually know. But it's this that is speculated. This is what we believe happens around a period of extreme glaciation. The Earth's orbit changes from the more circular, more circular. It's not circular at the moment, but it's almost circular than it is today, and it becomes a more elongated as it travels. Scientific term, it travels further away at. John's got to kill me. It elongates at the furthest point. I forget the precise term. Now, we don't actually currently know why the orbit elongates. This video is just essentially to say that we might be sitting on the reason. We might already know the reason, but just no one's put it together. No one scientifically put it together, but the logic is there. Now, at the moment, we define the changing of the orbit as something that affects the weather. If you've watched the other video that I've done, essentially I've gone into the bits about the Earth and how volcanology and plate tectonics can have a drastic effect on sea level, and specifically how plate tectonics, a shift in plate tectonics can have actually a massive shift in the global climate. I hinted on that. I didn't actually specifically say it. Now, what I specifically said was about how the Eye of Sahara, if there was a human civilization on the west coast of Africa, they would have been a lot closer to sea level, or they would have been roughly about the same distance from sea level as they are today, because of the continental plates shifting with the mass of ice. What I'm going to explicitly say in this video is that the shape of the Earth defines the Earth's orbit around the Sun. The shape of the Earth defines how the planet moves around the Sun. This is a very simple, very simple idea, and eventually what I like to do is I like to get some I may put something up in the corner or something, I don't know, but we can do experiments on this now. Spinning tops. If you have a flatter spinning top, or a more random spinning top, they tend to spin, or a coin, spin is very, and you spin them on the spot, the spin is completely different. Now, we can see this evidence, we know it happens, and yet when it comes to our planet, there is a failure to connect those schools of logic together. So what this inherently means is that volcanology, the planet itself, can be responsible for a change in orbit. How does this work? If you have a volcano, sun release a massive you need a mega volcano or several volcanoes going within a few years of each other, causing a chain reaction. But if you cool down a hemisphere of the Earth enough to start building up some glaciation, and you get a kind of runaway kind of weight in the hemisphere, and you can impact on what's happening subsurface to the magma with the cold temperatures, the ice, you can then start to get a runaway climate situation. And this runaway climate situation can essentially, just like the spinning tops, it can alter the rotation and of the Earth around the Sun. And that last bit is a runaway situation. So, especially when climate generally sticks into one hemisphere, so it's northern or southern. But when you have massive cooling of one hemisphere, eventually there is seepage from one hemisphere to the other. So eventually, if you have runaway glaciation going and cold spells going in the northern hemisphere, eventually it will spread to the southern hemisphere. And when you have one hemisphere, you'll destabilize, but when the second hemisphere goes, if you get massive glaciation, as we mentioned in the previous video, you get this kind of squash ball effect, which exacerbates the kind of centripetal kind of round the waist equatorial region that you get from the Earth spinning in itself, and this kind of, it just exacerbates that squash ball effect. So this exacerbated squash ball effect would stabilise the Earth's orbit. A key point I want to make in this video is that when you have runaway climate change in just one hemisphere, and the only way to get runaway climate change, localised runaway climate change, is through the planet itself, and that's through volcanology, or through eruptions or impacts. But eruptions are more likely because you've got the greenhouse gases, and you've got the sulfur, the acid rain. You've got everything you need. The planet has everything it needs to create this problem there already. So yeah, it's don't get me wrong. It's even working it through my head. I don't do these things. I'm not doing these things for the script, but it's a complicated issue to work through. But essentially, you have a runaway series of chain reaction of events, or one mega event in one hemisphere. This creates a climate issue in that hemisphere. The climate issue will eventually seep to the second hemisphere, the other hemisphere. However, at one point you have a runaway climate, and then you have a change in the Earth's weight, and you have a change in and this change in the distribution of mass within the Earth causes a change in the orbit of the Earth around the Sun. This can be affected by other planetary bodies as well, but we'll leave that one alone for another video. We'll focus on this system itself, the Earth system itself. So you have a greater pressure. This is a runaway. This is a runaway increase in pressure, and it will, when it spreads to the second hemisphere. The runaway, it's almost, you could almost say it's not, it starts to run away, but the point of no return is when it seeps to the second hemisphere. But at that point, the Earth stabilizes itself. It starts seeping to the other hemisphere. Is kind of like a stabilization effect. It stabilizes the Earth's orbit around the Sun, even though it makes it more regular again, but this would almost mean that for a short period where we're just in one hemisphere, the Earth's orbit around the Sun would be extremely irregular. Now I don't quite understand how that would manifest and how that would work. There's absolutely no evidence for that, because everything that we see when we look out in space is very regular, apart from asteroid bodies that are generally too small to have climate. So it's one of these things that it's going to take us a long time to actually figure out and work out, but the science is there, and it's something that we need to be linking, and it requires a little bit of a shift, because up until now we really assume that the shift in well, we don't actually know why the Earth shifts. We just know that every now and again the Earth's orbit seems to shift, and when it shifts, the Earth gets colder. We've gone through a couple of periods of snowball Earth. There's one massive, and through the major snowball Earth event that we remember, it was volcanoes that brought us out. All life almost, one of the snowball Earth, the main snowball Earth event, which was a mass extinction event. It's I forget which one it was, apologies, but it was volcanoes that brought us out of that event. And there was a massive series of volcanoes that punctured the ice caps, the glaciers and the snow, and actually started to warm up the Earth again, and started absorbing heat and sunlight. So whilst volcanoes and volcanic activity, it can do both things. It can cause the Earth to dramatically cool. If the Earth is too cold, it can cause the Earth to also heat up. It can cause the surface of the Earth to also heat up. And by the nature of volcanic activity, the magma is hot. So a way to look at it is, another way to look at it is, it's the Earth's blood. When a human or an animal kind of bleeds, now this is just me rambling on here, when the Earth, when we as humans or animals bleed or cut ourselves, the blood comes to the surface and the blood clots. Everything about magma that we know, although it's lava, although it's a completely different substance to blood, it works in essentially the same way. It kind of flows out, carterizes, not the right word, solidifies, in case of planet, in case of blood it carterizes. The only thing, the difference between blood and the planet is that we say blood is pumping essential nutrients around our body. Now, for that to be true of the planet, we have to assume that the planet is alive, which under some schools of thought, some people do actually believe that, if you believe the Gaia theorists. However, the Earth, even if you do want to just care about the planet and look after it, though we don't fully understand what the planet is, apart from the thing that gives us life, therefore we should look after it. Most people won't want to jump on board the fact with the planet the Earth is alive. I'm not sure if I truly believe it myself. All I know is that we need to respect it. However, there is one thing to be said for Lovelock and his ideas, and that is that the planet will kind of do what it needs to kind of, if the planet is in itself an organism, and it's a prime organism, we are just the bacteria, very much like the bacteria in our stomach are to us. We are to the planet like the bacteria in our stomach are to us. Then what's going to happen in the coming few years is going to be the planet's way to try and heal itself. Now, understanding more about how systems work is going to be essential moving forward, because if we start to go through, the key area to look at is if Antarctica starts to melt massively, we are going to have a situation where several miles of ice, several miles of pressure, which is currently on a continental, on a land, which is currently on land, will be released from the land, and the continental plates will shift as that pressure is relieved, and that water that's currently ice will flow into the ocean. So not only will we get a sea level rise, we will get continental plates shifting all throughout the world, and we will likely have some major tectonic and volcanic activity throughout the planet. Now, the reason for this video is just to explain that this new shape of the planet may cause other shifts. The Earth will need to almost the Earth may decide to change, wobble a little bit as the centre of mass changes, and while the Earth is wobbling, while the centre of mass is changing, the Earth might decide to wobble around the Sun a little bit more, which causes some more extreme weather events that we can only define as out of the ordinary. So yeah, this whole climate change thing is going to be rather drastic, but we're going to have to be very, very clever about how we are unpicking the event and trying to define exactly what cause, what effect, and what causes are linked together. Now that's probably going to be key moving forward, but we're moving on to another rambling topic there. The key issue here is that the planet itself can without human intervention change its shape, change its mass distribution, and change its climate. We are in a position where we are currently doing it, but we've just gone through the events. We can have a series of volcanoes erupting, spewing gases into the atmosphere. The gases cool down a hemisphere. If you have these events, one off over a period of years, you can get extreme cold spells, you can get extreme glaciation, and you start to shift the way the plates are moving. The key issue this video is trying to promote and to warn is that this can cause a shift, potentially cause a shift in the Earth's orbit, in how it orbits. Just like a spinning top, it's a wobble. The Earth changes its orbit. This can cause runaway, potentially the poles can start to wobble, or completely shift, but this will cause the climate to, the glaciation, the climate to spread to the second hemisphere, and then you have a stabilization. However, at this point, you almost have a runaway feedback loop in the new system. So the Earth has changed. The Earth has caused itself to change from one system to a second system due to change of mass and change of orbit, which allows it to cause a runaway with regard to things like climate. So we're impacting our planet at the moment, and we're causing these things that would normally happen naturally, and we just need to think slightly outside the box in my mind, and at the potential implications of what can occur in the future. So this is rambling video number 2. This is I'm Robert Harkis, computer scientist, scientist in general, jack of all trades. But yes, thank you for listening. Please comment below if you have any, if you want to discuss anything. Please cite evidence if you want to argue. Absolutely fine. I'm up for people with different opinions, as long as you back it up with evidence, and that's absolutely fine. Thank you very much. Have a good day.